So the main gist of everything we've done up to this point for graphing is that if it's in this format, y equals like 2 over 3 x minus 4 or something like that, we can graph it pretty easily because this gives us our beginning place, begins at 4, negative 4 right there, and this tells us where to move, the m, the slope, up 2 over 3 right here, up 2 over 3, and so on. So in this format, it's very easy to graph. So the next question becomes, like on your homework, what do you do if it's not in that format? How can you graph it? If we know how to graph when it's y equals so easily, what do you do when it's not y equals? So how do you get it basically to go from something like this to something like this, and that you can easily graph? Okay, so I'm going to show you a quick slideshow just with some examples. One handout's going to be the notes, the one with graphs is going to be the notes. We're going to do all that together, front and back, and the other page is your homework. Now you notice the page on your homework, you don't actually have to graph them, it's just solving. Okay, but we'll do a little graphing just for the practice. Okay, so just watch up here. This won't take very long, but it is very important. Pay attention. So this is the format we're used to that I just showed you. It's y equals mx plus b. In another sense, it's y equals a number with variable x plus or minus some beginning point on the y-axis, right? Plus or minus a number. Okay? And of course, the m is how it moves, the green part, and the number on the end is where you begin, the starting point or the y-intercept. Okay? And keep in mind that everything we're doing is for prediction purposes. If you want to know what's going to happen in the future, you have to know two things. Where are you starting from, and how fast are you moving? So if I ask you the question of how long will it take to get to, assuming you're anywhere, how long will it take you to get to Chicago, you have two questions to ask. Well, where am I starting from, and how fast can I move? Then you can figure out how long it takes to get there. But you need to know those two things, and that's what those two numbers stand for. The number, the blue, was where are we starting from? The green is, well, how fast are we moving? With that information, I can find out and predict anything that will happen. Okay? So here's the format we're used to. And here's what we've been doing. You find the slope to find the y-intercept. Slope is 3. The beginning point's at negative 2. We always started, with that starting point. Makes sense. Start with the starting point. And then figure out how fast you're moving. And if it was just an integer, like this is 3, we make it 3 over 1. So up 3 over 1, up 3 over 1. So we can graph anything in this format pretty quickly, pretty easily. And that's what you're practicing on the warm-up a lot. Okay. Now the question is, what if it's not in that format? Like this one. This is not in that format. Can you see why? Alright. And use the model at the top to help you out. Is it y equals a number variable plus or minus some number? No, this is not. Neither is this. It's not y equals. Neither is this. So how can we take each and every one of those and put them in the correct format so we can easily graph it? Okay, so something like the first one. This one's the easiest of the cases. Doesn't happen too often, but just still important. It's still y equals, but the green and the blue part are in the reverse order. The number and the variable is on the right-hand side, and the plus or minus one number by itself is right here. So we just need to switch them. Okay? So basically you need to take that negative 2x and just put it right after the equal sign and know that that's a positive 3. 3 is the same as plus 3. So that's the easiest type of fix. It was already y equals, just had to make the order on the right-hand side correct. So the slope is negative 2, and the starting point, the b, is 3. Same thing here. Y equals, but think it's in the wrong order. Just imagine moving that around. And I'm using minus a lot just to show that if you move these, the negative comes with it. Remember, a negative and a minus sign are the same thing. Don't just switch the 4 and the 5 and make it 4x minus 5. You have to bring the negative or the minus sign with that 4. Okay, very important. Okay, so we got a slope of negative 4 or down 4, right 1. And then the starting point is 5. Okay, or the same. Okay. Next, the middle case is, what if it's not y equals at all yet? We have x and y on the same side. So here's where we can use some of our equation solving techniques. If we want to cancel something out on a side, you can do its opposite or inverse. So in this case, if we have a positive x, we can always subtract x. Right? And I'm color coding these so you can see where everything should end up. It should be the orange equals green and then the blue part. It should be in that order. So if I subtract that just equals 0 and cancels out. But be very careful over here. You do not want to make it 5 minus x. You want the green, then the blue. So put the negative x or the minus x right after the equal sign. And there you have it. You can graph that. The slope is -1. You start at 5. Okay. Remember, that's -1 over 1. Down 1, right 1. Down 1, right 1. So you have to go from just a minus x, and know that means down 1, right 1. Equals -1, which is the same as -1 over +1. Okay. Same thing here. No, I'm just waiting for a few people. Same thing here. We have a minus 2x, so you have to add 2x, make it 0. And then don't just make it -3 plus 2x, but put that 2x right after the -3. Okay. Now you can get your slope, just 2, or up to right 1, starting at -3. Okay. Here's the last kind. It's a two-step. And the difference is that there is a coefficient in front of the y. So even though if we add x to both sides, do what we've just been doing, it's not y equals, right? That's not in the correct format. Because it's 2y equals. We need y equals. So 2 times y, how do you cancel out 2 times? Divide by 2. So one more step. Divide by 2 on both sides. 2 divided by 2 equals 1. And we make it go away. Don't have to write 1y, just y. Now on the right-hand side, do you divide the x by 2 or the 6 by 2, or both of them? Okay. So it's distributive property. You don't have a choice. You have to divide everything by 2. So divide both of these by 2, not just one of them. Distributive property, so you don't have a choice. You've got to just divide everything equally. So we have x over 2 plus 6 over 2. And simplify whatever can be simplified. Remember, x is the same as 1x. 6 divided by 2 is 3. And then we usually put the x, we kind of move that away a little right there. So we have 1/2 x plus 3. Now it's a slope of 1/2 up 1 over 2, starting at 3 on the y-axis. So just a few more, just watch and observe. See if you can guess the steps before I do them. What would I do first here? How should I write it on the right side? Not quite there yet. Divide by -2. On the right-hand side, divide both of these by -2. Not just one of them, but both. So that's -1x over -2, right? Because -x is the same as -1x. Plus 2 over -2, and then simplify anything that can be simplified. So the blue, what's 2 divided by -2? Okay. And what's -1 over -2? Okay. Positive 1/2. So negatives cancel out. So that's going to be your process for majority of your questions here. Okay. So let's practice a few. Just copy down everything I go through. There's not a lot of room, so I'm going to be writing on side to side as well. But something like number 1, very similar to what we just did. It's almost y equals. There's a positive 2 there. I'm just going to subtract 2 on both sides, and then make sure you put in the correct order. We have y equals 3x minus 2. Number 2, very similar. I'm going to go back and do the graphing in a moment. Just focus on the new part. This one is a minus 2, so I have to add 2. So just like before, when you're adding and subtracting, you need opposite signs. One's positive, one's negative. So we have y equals 3x plus 2, all right? And lastly, add 2 to both sides. And there you go. So those were the medium, pretty simple case. You just had to add or subtract one thing. Notice how there's no number in front of the y, so we didn't divide both sides by anything here. Okay, so let's go through and just graph those. Identify the slope and y-intercept, and then graph them. So slope on number 1. Is 3. Which is the same as 3 over 1 to graph it. So if I ever ask you the slope, you can just say 3, but if you have to graph it, you need to write 3 over 1. You need the rise and the run. And the y-intercept is negative 2 right there. So I'm going to start at negative 2 and then go up 3, right 1. So let's see here. Start at negative 2. On the y-axis, negative 2, and then go up 3, right 1. And you do it several times just so you can get a straighter line. There you go. And of course, use a straight edge only when you're graphing. I'll be checking homeworks tomorrow or Wednesday. If all your graphs, all your straight lines supposedly are hand-drawn, you'll get zeros until you use a straight edge. It's not an option. It's not kind of, or just use the tools that are available, right? Use a straight edge to graph straight lines, period. Nothing kind of close to that, but always straight. All right, keep this going. So we got, again, a slope of 3, which is, graphing is 3 over 1, up 3, right 1. And then the y-intercept, the starting point, is positive 2 here. So start at positive 2, up 3, right 1. Do that several times. Straight edge. There you go. Put arrows at both ends. There you go. Number 3, very similar. It's just that it's a negative 3 slope. So the slope is down 3, right 1. Starting at positive 2. Start at positive 2, down 3, right 1. And finish it up. Okay, that's just the beginning, and those are like the medium level. Didn't have to divide by anything, no distributive property, anything. Pretty straightforward. After all this, the most common mistake, of course, will be negative. So if this seems really easy, remember, everybody that thinks this is easy doesn't get 100% on it, usually because it's too easy and they rush through it and they miss the negatives, the little details, the smallest details. So take your time, even if it seems easy. Exercise patience. All right, starting at number 4. 5 and 6. Here's where we have 2 steps. I can see that because there's a number in front of the y. Y has a coefficient of 5, so I know I'm going to have to divide by 5, divide by negative 5, and so on. So it'll be a little bit more steps here. So let's start the same way. Let's subtract that x on both sides. All right. So I'm going to have 5y equals, now remember, make that negative 2x right after the equal sign. We want it in that order. And here's what's new on number 4, is that we have a coefficient of 5 in front of y. So I'm going to divide by that same number everywhere else. So 5 divided by 5, now we have y equals, now you have to divide both of these, right? Both of these you have to divide by 5. So negative 2 divided by 5 is just negative 2 divided by 5. Now if that was like 4 over 6, you could reduce it to 2/3. So reduce it when possible. And 5 divided by 5, okay, don't forget the x, and then plus 1. So we have a starting point of positive 1. We're going to start at 1, and then we're going to go down to right 5. Starting at 1, down to right 5. Do that a couple times. Let's see, that doesn't look like it's straight. Down to 1, 2, 3, 4, 5. Down to 1, 2, 3, 4, 5. There we go. Oh, I missed it. Okay. There we go. That looks like it's straight. Yeah, if your dots, if they don't line up on a straight line, that usually means you counted dots wrong. If you caught what I just did. I didn't go down 2, I went down 1, right 5. And then when I tried to draw a straight line through it, I couldn't. They didn't line up. So if you find your dots are not lining up and you can't draw a straight line through them, it means you counted your squares wrong, which again happens when you're in a hurry, going too fast. Okay. Let's do a few more. It's a positive 2x, so I'm subtracting 2x to get 0. So we have negative 5y equals negative 2x minus 5, and then finish by dividing everything by negative 5. Same sign. So that cancels out. Y equals. We'll have negative 2 divided by negative 5. So negative over negative, positive. And then negative 5 divided by negative 5, positive 1. Negative divided by negative is positive. So we're going to start at positive 1 and go up to right 5. Start at positive 1, up to, and right 5. 1, 2, 3, 4, 5. Up to 1, 2, 3, 4, 5. And if you have a straight line that can go through all the points, then they're probably lined up correctly and counted properly. So yeah, if you miss one little negative, you could have a negative 2 over 5, and it'll be going it won't be going close to what the right answer is. It's completely opposite. That's one thing about this. A negative doesn't change it a little bit. It makes it a completely opposite graph. It's going down instead of up. Or it's at negative 1 instead of positive 1. Now try number 6 on your own. See if you got the hang of it. See if you can do it. Use 4 and 5 as an example. Give it a shot. I'm sure you guys can do this. Okay, check what you got. Did you get this? Up to right 5. starting at -1. Start at -1 up to and right 5. Remember to draw your line across the entire graph, arrows at either side. Alright, so there is page 1, front side. Using a straight edge only for those straight lines. Nothing hand-drawn. I'm going to skip a few just because it's a repetition. But, well, how about let's just 7, 8, 9, let's just solve but not graph. So let's go through 7, 8, 9, solve but don't graph. So ask yourself before you begin, at this point, can you figure out what you're supposed to do before you start anything? So can you imagine or picture, first I'm going to subtract x on both sides, then that will be gone, then it'll be a -2y, so next I'm going to divide by -2 on both sides. Kind of have that plan before you even start, know what you're going to do, and then carry out that plan. So start off by doing the subtracting. And then doing the dividing. Divide by -2 both sides. So we get +1, y. We'll have -1, right? -1 over -2, x. And we'll have -4 over -2 for our starting point, which is +2. So I'm going to go up 1, right 2, and then starting at 2. Go up 1, right 2. So I know there's not a lot of space on here, but in your homework you can do the work on the back or accept a piece of paper. You can have small, neat writing. You can do it on the front. But yeah, the common mistakes will be negatives here. So watch when you have 2 negatives. Make sure you change them to a positive, and it should be okay. Yeah, the homework, there's some room to do it on the front, or you can use the back just to make sure don't make mistakes. Okay. Hey, this last one. Then I'm going to skip to 10 and 11 because they're a little different. And we can, yeah, the purpose of these few is just to practice having all those negatives floating around and how to simplify negatives. As long as you're writing neat, right, you'll be okay. If you're writing too small, it's when those negatives disappear. So we have -3 over -4. So that's 3 over 4 when you simplify, x. And -12 divided by -4. We have +3. So I'm going to go up 3, right 4, starting at 3. If you skip down to 10 and 11, what's different about those equations? There's something fundamentally different about them. Yeah, there's only one variable. So recall, what does it look like if you graph something that only has one variable? Okay. So the fact that it has 2 variables is what makes it diagonal. You can move across the x-axis and the y-axis. You've got 2 dimensions because you have 2 variables. If you have one variable, that means you only have one dimension. Okay? So if you have one variable, you only have one dimension, which means you can only move, if you had x equals 5, it only moves up and down. It can't move left and right. It only has one variable. That's only one direction. Every variable counts as a direction. And same thing as if we had y equals 5. That can only move left and right. Right? So one variable means no diagonal. It can only move left and right because it's only one variable, one dimension. Right? So when you come across something like this, and you only see, wait a minute, there's no y there. Right away, that's a giveaway that, well, it's only moving in one dimension, in one direction. It can't move diagonal, can't move up and down and left and right. So something like number 10, where it doesn't have a y, it kind of breaks all the rules, because we just got finished saying, well, we want y equals everything, but if the original equation it has no y, well, you can't do that. You just have x equals -1. Right? There's no slope. The slope is undefined. Right? Because it's a vertical line. Some people say, well, the actual letter x reminds them, like this is like a letter V for vertical line. So they remember that, okay, that's just going through the x-axis. All right? This is weird because we're looking at an x-intercept at -1, and it's just a vertical line at -1. There is no y-intercept. It does not cross the y-axis at all, so none. Yeah. So the vertical lines are the weird lines. You can't write it as y equals because there is no y to begin with. The slope is undefined. It's not even a number. And there's no y-intercept at all. So you can't write it in slope-intercept form, the y equals mx+b. We can't do any of that. It's just different, fundamentally different from all the others. And if you remember from before, it's not a function. The straight line goes through 2 points. Vertical line goes through 2 points. It's not a function. So everything's different when there's no y involved. Whereas in 11, there is a y involved. It's just y equals 5. Right? Which looks like this. Y-intercept of 5, but the slope is 0. The rise is 0. It doesn't go up. So the slope is 0. The y-intercept is 5. So here, y equals 5. 1, 2, 3, 4, 5. There we go. Okay. Now, I don't believe there's any on your homework with the vertical lines. There are with the horizontal lines, but not the vertical. So it's just something to keep in mind. X equals is a vertical line. Think of that top part of the letter X as being a V for vertical. It's an undefined slope. There is no y-intercept because it never crosses the y-axis. And we already looked at these a little bit when we were graphing. We made that box using decimals. So there's most of your examples there. Your homework. Let's see here. Thank you. Wait for it. There you go. Your homework looks like this, in which you just need to take the equation, write in the slope-intercept form, and identify the slope and the y-intercept down here, and then put the letter. And it should spell out some awful joke. Okay? But at least you'll know that it's correct. That's the important thing. Don't just write it down, put letters down, and they're completely random and say you're done. If it doesn't spell out words, at least you know something's up. Okay. Now, let's see here. Let's look at get all these. There we go. Do any of these, are any of these vertical or horizontal lines? Looking at all the equations, what letter? And what gives it away that it's a vertical or horizontal line? Yeah, one variable, one dimension. So yeah, v would be y equals 2. You know that's a horizontal line. Slope is 0. H is a little weird. I want to show you H just because we didn't do any examples like that. But everything is on one side on H. So just keep in mind our goal is this. Y equals our slope, x, and then some number. So we need to get y by itself, which means I need to subtract the 4x and subtract the 3 on both sides. And divide by -6 both sides. Now be careful, what is -4 over -6? Don't say 4 over 6. Positive 2/3. So we have the negatives to figure out to make positive, but the 4 over 6 to reduce to 2 over 3 as well. So we got both. And then be careful, -3 over -6, don't say 2. What's -3 over -6?
1.
So negatives cancel out, and when you reduce, divide top and bottom by 3, you get a y-intercept of 1/2. Right? So we have m equals 2 over 3 up 2 over 3, starting at 1/2. Now, usually the y-intercepts, the starting points aren't fractions, but they can be. And you can see that down here in the answer key, that, yeah, there's some, here has a -1/2 y-intercept, -7 over 2. So, yeah, you can have fraction y-intercepts. It's not a problem. You can graph a decimal. Well, you're not graphing these, so it doesn't matter if that's a fraction. But don't freak out because, well, 2 doesn't go into 7. What would I do? Just 7 over 2 is fine. Okay? And I think that's about it.